Linear and Quadratic Functions by Taylor, Will, Haley, Connie, and Walia.
Our first function is a linear function. Our example function was f of x equals x. Both the domain and range include all real numbers. For this particular example, y approaches infinity as x approaches infinity, and y approaches negative infinity as x approaches negative infinity. The symmetry of this function is odd.
The function is not bounded with no asymptotes or discontinuities. In this example, it increases from negative infinity to infinity and does not decrease. It also has no extrema.
Our second function is a quadratic function. The equation of the function is y equals x squared. The domain is from negative infinity to positive infinity. This means all real numbers. The range is from 0 to infinity. For the end behavior, as x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y also approaches positive infinity.
There are no discontinuities in this function. There are two extremas, a local minimum of 0 at x equals 0, which is also the absolute minimum. There are no local or absolute maximums because the graph continues upwards indefinitely. The graph is decreasing from negative infinity to 0, and then increasing from 0 to infinity.
This function is bounded below, not above, and there are also no asymptotes because there's no gaps within the graphs. The symmetry is even.
Hello, my name is Max, and our group had the cubic function. The parent function of this is known as y equals x cubed.
I'm Shahir. Here's a graph of y equals x cubed. There are points at -1, 1, 0, 0, and 1, 1. The symmetry of a cubic function is odd because, as you can see, it is symmetrical with respect to the origin. What that means is we can flip it over the x-axis and the y-axis, and it will be symmetrical with its other half. Domain and range. In a cubic function, all x values are possible within the domain. Also, all y values are possible for the domain. This can be seen by the pattern of the function on the graph.
Hi, my name is Alea. Cubic functions don't have asymptotes because the graph touches all x and y values. It doesn't have any discontinuities because the graph is all continuous that works with any value. It increases from negative infinity to infinity. It is not a bounded function because it continues forever, and it has no extrema because it's always increasing. And its end behavior is the limit of f of x as x approaches negative infinity is negative infinity. Also, the limit of x as x approaches infinity is infinity.
The inverse linear function equation is y equals 1 over x. The points we chose for this function are -1, -1, and 1, 1. These coordinates are opposite of each other because the equation y equals 1 over x. The domain of this function is negative infinity to 0 and 0 to infinity. This means that values from negative infinity to infinity are included besides 0. This is the same for the range. The end behavior is as x approaches negative infinity, y gets closer to 0. As x approaches infinity, y gets closer to 0 too.
For the symmetry, this function is odd. It reflects across the origin horizontally as well as vertically. And the function is not bounded above nor below because it does not have a maximum or minimum value.
The function has a horizontal asymptote of y equals 0, as well as a vertical asymptote of x equals 0. As for discontinuities, we have an infinite distance gap because every number from negative infinity to infinity are included besides 0. Since 0 is not included, that is where the hole is located, or rather, asymptote.
This function is both increasing and decreasing in every direction, so it is considered mixed. There is no extrema because there is an infinite amount of numbers included in the function.
For our next function, we had the square root function. The parent function of this is known as y equals the square root of x.
Here's a graph of y equals square root of x. The values start at 0, 0 and have other points at 1, 1 and 4, 2. This function is not symmetrical because it can be reflected in respects to either x's or the origin. The domain includes 0 and continuous positive without bound. The function can't have x values less than 0 because that would give a negative number under the square root. The range includes 0 and continues positively without bound.
Square root functions do not have any asymptotes. The x and y values do stop at 0, 0 because the domain and range can't go below 0. There are no discontinuities because the function is continuous. The function is not bounded above, but it is bounded below because there are no values below 0. The function is increasing from 0 to infinite and is never decreasing. The extreme has an absolute minimum of 0 at x equals 0. This can be seen in the graph as the values stop at 0, 0. The end behavior for a square root function is the limit of f of x as x approaches negative 0 does not exist, because the function has a limited domain and range. The limit of f of x as x approaches infinity is infinity.
We said for the domain that it was negative infinity, infinity, and the range starts at 0 and ends at infinity. So for slide 2, we have our exponential function. F of x is e to the power of x. For this function, we were also given two different functions, which was y equals 2 to the power of x and y is 1/2 to the power of x.
So there is no symmetry since the function is neither even nor odd. With the boundedness, this function is bounded below. For asymptotes, y is set equal to 0.
For discontinuities, we said that it continues at all x, so the function is non-removable and it increases at negative infinity, infinity. For f of x 1/2 to the power of x, it decreases at negative infinity, infinity. There is no extrema occurring, and for end behavior of f of x 2 to the power of x, the limit of f of x as x approaches negative infinity is 0, and the limit of f of x as it approaches infinity is infinity. For f of x of 1/2 to the power of x, the limit of f of x as it approaches negative infinity is negative infinity, and the limit of f of x as it approaches infinity is 0.
Alright, so, is it on? Okay, so first we're going to go over log functions. So, parent function of a log is f of x equals log b of x. So, here's the graph sideways. And then, so there's going to be no symmetry here, and there are no bounds. There is a vertical asymptote at x equals 0, and there's going to be no discontinuities.
The function increases from 0 to infinity and has no extrema. The domain of this function is from 0 to infinity, and the range goes from negative infinity to infinity, or all real numbers.
So next, we have absolute value functions. The parent function of an absolute value equation is f of x is equal to the absolute value of x. This has an even symmetry with respect to the x-axis and is bounded below. There are no asymptotes and no holes, so no discontinuity.
This function is decreasing from negative infinity to 0, and then increasing from 0 to infinity. It has an absolute minimum of 0 at x equals 0. The domain is from negative infinity to infinity, and its range is from 0 inclusive to infinity. Its end behavior is the limit of f of x as x approaches negative infinity equals infinity, and limit of f of x as x approaches positive infinity to positive infinity.
The next function is called the greatest integer function, also called the floor function.
You can also see this function expressed as y equals integer x, y equals floor x, and y equals x in double brackets, or as a step/floor function. The graph of the greatest integer function looks like steps because it only includes real integers. The open circles are points not included, while the closed circles are points included within the function.
The domain of the greatest integer function is from negative infinity to infinity with a range of all integers. This function has no symmetry, boundedness, or asymptotes. The function has jump discontinuity at every integer.
There are no increasing or decreasing intervals. The constant is described as bracket k plus 1, close parentheses, where k is the element of all integers. The left end behavior says the limit of f of x equals negative infinity as x approaches negative infinity. The right end behavior says the limit of f of x equals infinity as x approaches infinity. There are no extrema in this function.
So we have logistic functions, and the equation is 1 over 1 plus a times b to the x. The function has no symmetry, no discontinuities, and no extrema because it continually moves up until the asymptotes forever.
The function has horizontal asymptotes at y equals 1 and y equals 0, and it intercepts the y-axis at 0, 0.5.
The domain of the function is all real numbers, so negative infinity to positive infinity, while the range is from 0 to 1.
This equation is bounded both above and below, and is always increasing, never decreasing. The end behavior is lim f of x equals 0 when x is approaching negative infinity, and lim f of x equals 1 when x is approaching infinity.
This is the parent function of the sine function, and the equation is y equals sine of x.
The domain of the sine function is all real numbers, negative infinity to positive infinity, and the range is negative 1 to positive 1.
The sine function is symmetrical to the origin, which makes it odd. The function is bounded above and below, and it has no asymptotes or discontinuities.
In regards to extrema, the sine function has an absolute max of 1 at x equals pi over 2 plus 2 pi k, and this is because it's repeating. K is an element of the set of all integers, so plugging in an integer for x would give you another max. The function has an absolute minimum of negative 1 at x equals 3 pi over 2 plus 2 pi k.
The end behavior for the sine function does not exist, whether x approaches infinity or negative infinity.
This is a cosine function. The domain is negative infinity to infinity, and the range is negative 1 to 1. Negative 1.
The symmetry is mirrored along the y-axis and bounded above and below. There are no asymptotes or discontinuities. This is an even function.
The absolute minimum is at y equals negative 1 at x equals 0 plus 2 pi times k. The absolute maximum is at y equals 1 at x equals pi plus 2 pi times k. K can be any integer. The end behavior does not exist because when this is an oscillating function where it doesn't reach any endpoint.